Okay, now let's look at indirect proof. Indirect proof allows us to prove the negation of a sentence, which we assume and then show leads to a contradiction. So it's sometimes called proof by contradiction. Here's a sketch of a famous example of a proof by contradiction. Suppose we assume that there is a highest prime number, call it k. Well, if I can show you that there's a way of making a new prime number out of k that's higher than k, then k both is and isn't the highest prime number, and our initial assumption that there was a highest prime number is false. We'll see some more basic examples of this in what follows. Now we move on to indirect proof. This is sometimes called proof by contradiction, or reductio ad absurdum, which is just Latin for reduction to the absurd, or in Fitch is called negation introduction. The basic idea is that in the course of a proof, you assume the opposite of what you want to prove, reach a contradiction, and this allows you to introduce negation, to contradict this original sentence up here. Let's see an example of this in action. Suppose these are our premises. A is large and B is small. And suppose our goal is to show that A is not the same as B. What we do then is we temporarily assume that A is equal to B. And it's easy to see how this leads to a contradiction because it commits us to the claim that A is both large and small. And from this, we're allowed to derive the negation, which is A is not equal to B, and that was our goal. So in order to carry out negation introduction, we first assume the negation of what we want to prove, and then we derive a contradiction. We're just using this upside down T to mean contradiction, and we're going to use it that way throughout the rest of the course. This is an extremely powerful tool, and it actually allows us to get rid of negation under certain circumstances as well. I'll show you what I mean. Suppose we have a series of premises, P1 through Pn, and we want to show S. What we can do is assume the negation of S, then derive a contradiction, which leads us to not S. But we saw earlier that double negation just gets us assertion, so this brings us right where we wanted to. So in plenty of circumstances, you can actually prove an affirmative by assuming it's contradictory negative, deriving a double negation, and then taking off the negation altogether. One further notion, just to clarify before we wrap this up, is TT contradictory. A sentence that's truth table contradictory is false in every row under the main connective. This brings to mind a contrary notion of TT necessity, which we saw in an earlier video, where a sentence is TT necessary, truth table necessary, if it has a T in every row under the main connective. It turns out that any negation of a TT necessity will be TT contradictory, of course, because the negation flips every T in the TT necessary sentence. Here's an example. We already saw that A or not A will be true in every instance. Under the main connective here, we have all T's because this is TT necessary. But suppose we negate this. This means that the negation sign is our main connective, so we're looking over here. And because it's a negation sign, it flips these values, TT, and we get false, false. So this is a TT contradictory sentence, not A or not A. By De Morgan's laws, it's also equivalent with A and not A. If you like, you can try pushing the negation through and seeing how this works, and then construct a truth table for A and not A to see how it gets the same values as not, parenthetical A or not A. So this is a nice exercise to do if you want to keep working on these concepts.